Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam, there is a clockwise concentrated movement 216 kilonewton meter. It acts at a distance of 4 meter from the left support. The span of the beam is given as 6 meter. We know that the upward deflection due to RB will be equal to the downward deflection due to the concentrated movement. In this case, we can use this expression, then we can eliminate EI. Finally, we will get this. Now, from the point B and about the point A, we are going to find the moment values and draw the bending moment diagrams. In this case, we have to follow left-hand side rule. Clockwise will be negative and anti-clockwise will be positive. RB is acting in the anti-clockwise direction, so that it will be positive, and the distance is 6. RB into 6, we will get 6 RB, and the diagram will be in the shape of a triangle. The moment 216 is acting in the clockwise direction, so that it will be negative, and the diagram will be in the shape of a rectangle. Now let us find area 1 x1 bar. We know that it is a triangle. We know the area formula of a triangle, half into BH. Here the breadth is 6 and the height is 6 RB. So this is the area. Let us find x1 bar. For this triangle, we have to find the centroid distance about the right side, that is 2 upon 3 into breadth. Here the breadth is 6, so 2 upon 3 into 6. For area 1 x1 bar, we will get 72 RB. Now let us find area 2 x2 bar. We know that it is a rectangle. For the rectangle, we can easily find the area. The area is 216 into 4. Let us find x2 bar. We know that for a rectangle, the centroid lies in the center. When we divide 4 by 2, we will get the centroid distance, but we have to add the remaining distance also, that is 2. So 4 upon 2 plus 2. For area 2 x bar 2, we will get 3, 4, 5, 6. In this expression, we have found both of them. Let us apply them. In this way, for RB, we will get 48 kilonewton. Now let us find RA. In this beam, there is no load, so the values of RA and RB will be same, but they will be in the opposite directions. RB is acting in the upward direction, so RA should be acting in the downward direction. Now let us take moment about A and find MA. RB is acting in the anticlockwise direction, so that it will be positive, and the distance is 6. So 48 into 6. The moment 216 is acting in the clockwise direction, so that it will be negative. Let us assume that MA is acting in the clockwise direction, so that it will be negative. Finally, for MA, we will get a positive value. That means our assumption is correct. Here you can see the shear force diagram. Now let us find the bending moment in the point A. Here we can use right hand side rule because it will be easy. In the point A, we have MA, which is acting in the clockwise direction, so that it will be positive. To find the bending moments in the point C, we can use left hand side rule. Let us find the bending moment at just right of C. RB is acting in the anti-clockwise direction, so that it will be positive, and the distance is 6. Now let us find the bending moment at just left of C. With this value, we have to add the moment 216. Since it is acting in the clockwise direction, it should be applied as negative. 96 minus 216, we will get minus 120. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. We can make a section in this point and find the distance. You can see that in that point, I have made a section at a distance of x from the point A. We know that in this section, the moment is 0. Using that concept, we can find x, which is 1.5. Let us apply that. Now we are going to end this session. Thank you for watching this video.